Imagine watching a swiftly decaying particle that suddenly stops changing because you look at it. We are learning about the Quantum Zeno Effect, or QZE, where observation influences time. First, we will define the effect, then explore the underlying physics and look at a simple equation. The Quantum Zeno Effect describes how frequent measurement prevents a quantum system from evolving. If left alone, a quantum system naturally changes its state over time, like radioactive decay. This idea sounds like the classical Zeno paradox, where an arrow can never reach its target because it must first cover half the distance. However, the classical paradox is a philosophical puzzle about motion and infinite division. The quantum effect is a proven physical reality about the state of the particle itself. When a quantum particle is measured, its wave function collapses, forcing it into a single, definite state. This measurement process is called projection onto the initial state. If we measure the system quickly and repeatedly, we keep forcing the particle back to its original state. This repeated projection means the system never gets enough time to evolve into a different state. We can represent the probability of the system staying in its original state, P(t), over a short time interval, t. This probability P(t) is approximately 1 minus 1/2 times omega t squared. Omega represents how quickly the system would naturally evolve if left undisturbed. Worked example. Since the time interval t is squared in the subtraction term, making t smaller dramatically increases the overall probability. If we double the measurement frequency, t is halved, making t squared 4 times smaller, and the probability of staying the same rises quickly toward 1. Reflection. The effect highlights how the act of observation is an active process that fundamentally interrupts quantum evolution. To summarize, the Quantum Zeno Effect demonstrates that frequent measurement locks a quantum system into its starting configuration. This remarkable freezing ability reveals the profound and surprising role that observation plays in quantum physics. Generate your own educational videos for free at eduvids.vercel.app.